So, ladies and gentlemen, welcome to my presentation and best wishes from Germany to Ukraine. I will speak shortly about a project which we are doing in cooperation with KNUKA, Dnipro University of Technology, University of Bamberg in Germany, and Oldenburg University. And this is about a simulator for terrestrial laser scanning that can be used for e-learning and distance learning purposes without having a real scanner. As many of you may know, I have worked together with my colleagues in Kiev since about 12 years already, starting in 2011, and with joint projects, exchange of students, joint lectures, guest lectures, and also modernization of new courses, some research activities, and also some activities in business development. And we just have finished the last Intergeo in Berlin last week, where Ukrainian companies could present their products and services free of charge. And this was one benefit of our cooperation, because I could manage to offer these booths and stands for free. So, but now I will speak about the purpose of our project. I mean, you know, everybody, hopefully, that 3D scanning and modeling is state of the art. That we need 3D point clouds for many purposes. However, we have quite expensive instruments that hardly can be afforded by Ukrainian universities or other universities in the world. But we need that for construction, for reconstruction, for BIM modeling, for cultural heritage applications, for measurement of infrastructure, disaster demolitions, for city mapping, road mapping, natural monuments, and many more. And I know most of you are familiar with these applications and with these technologies. But this was is the current situation. So, here we have an example from the teacher's house in Kiev, has been done by Denis Gogovchuk from KNUKA some years ago already, and from that a BIM model could be created. For those who are not so familiar with BIM, this is a basic technology today to combine different types of information into the whole process of planning, building, maintaining of buildings or roads or infrastructure objects like bridges, etc. So BIM functions and BIM software like Autodesk Revit are widely used, and therefore we as geodesists, as surveyors, have an important task to create the necessary data. Of course, only those data that we can create, like shape and size of buildings, interior and outside of buildings. But of course, these data has to be combined with other infrastructural data like power lines, materials, and other information. Here we have a model of the 3D, of an industrial site in 3D, so you can see the complexity of such plants and factories, where BIM and also CAD modeling is necessary to maintain the factory, to plan new resources, to rebuild it, etc. This is an example where my colleagues from Georgia and we have measured old churches in Georgia, in Tbilisi, in a combination of UAV or drone photogrammetry with terrestrial images and laser scanning, all in one project, all in one software, which was reality capture. And you can see the level of detail, the accuracy, the completeness of such 3D models, which are generated completely automatic. I must emphasize this, because the software allows to match all these different sources of information in once. You know the disaster of the Notre Dame Cathedral in Paris, where luckily a 3D model or a point cloud was existing before the Great Fire happens. And by this data, it is now possible to reconstruct the Notre Dame and rebuild it, even with more information like how pedestrians are walking in case of emergency, how they can escape from a building, etc. This is all now done digitally in a BIM software. And this is also an example from Kiev, where you can, of course, scan those valuable objects and monuments in advance in the case something may happen to them or they will be destroyed, so there's a chance to reconstruct it. Of course, these are only a few examples of many, many which are around. Now our project was funded by DAAD, the German Association for Academic Exchange, since 2019, so for about 4 years already, together with our partners. It is a special program to support Ukraine from Germany, and we got the possibility to be funded from that program. So our motivation was, as already mentioned, to replace real instruments by virtual devices so that students can learn how to do laser scanning without having a physical instrument. That was even more important with the pandemic, with the COVID crisis, where people could not access the universities. So we can do online training with students and with teachers, of course. We can use modern augmented reality, virtual reality technologies, and we can use the modern technology of games, computer games, to support this kind of learning and teaching. The solution was that students and teachers can be trained on virtual systems that are very cost effective, or let's say they are for free. They are very flexible and they are very future oriented. Our cooperation partners, as already mentioned, is KNUKA from Kiev. It is the University of Bamberg in Germany, and since in the last period of the project, also Dnipro University of Technology. Maybe colleagues from Dnipro are here or in presence in Kiev, so welcome and hello to them as well. Here you can see a short video about how the scanner looks like. So we have a 3D scene, an environment where you can place your scanner, you can place targets, you can move around, you can walk around like in a video game. And we can also demonstrate the software briefly if we have time after my presentation, if you are interested. Within the software, we have different professional scanners from Leica, from Faro, from Trimble, and we will include other scanners as well. They will look like the real instruments. They have the graphical user interface as the real instrument. So all functions are exactly the same as in reality. Then after you're setting the stations and they set the parameters and the targets, you can see the green line here in the left image, which shows how the laser is scanning the virtual object, the 3D object, and we calculate simply the intersection point of each laser ray in space and got the 3D point cloud. And the point cloud can be seen on the right-hand side of the screen, where you can see that this looks really like a real point cloud with all noise, with all occlusions, with all problems that appear in reality as well. We have some scenes integrated into the software, which are historical buildings from Bamberg, an urban street scene, a villa from inside and from outside. But now this will be also possible to include your own 3D environments so that you can use it in that environment as you want. The software architecture and the workflow looks briefly like this. So on top we have the 3D model of the environment, a BIM model typically with material properties, etc. We have a laser scanner with its technical specifications, and we have some settings for the scanning, then a graphical user interface
є встановлення, сканування, і потім, як ви бачите, інтерфейс TLS, праворуч ви бачите деякі приклади, ви бачите модель Leica, це реальна модель, як сканер. Leica представив. Ви здійснюєте віртуальне сканування, отримуєте хмару трьохвимірну, і потім ви транспортуєте ці дані. Є додаткові пакети програми для реєстрації, якісного аналізу або моделювання, порівняння.
The software interface is E57, so this is state-of-the-art point cloud format, including also color values. Here's the work plan of our project. So we started with software development, we established some training courses. We have done project weeks where students from Ukraine and Germany work together in reality to compare the virtual scanning with real scanning. And unfortunately, due to the pandemic and due to the Russian invasion, we could not fulfill or could not conduct the summer school, which was originally planned. But we have also created a lot of teaching material, and already the virtual scanning is now part of the curriculum. We have done a lot of testing with students to check the performance and the use of the virtual scanner. We have very good results, so that is really close to reality what they are doing on their computers. And then they can go out and do the real measurements as they have already simulated, and so they can avoid a lot of mistakes. They know what to do much better than before.
Таким чином можна уникнути багатьох помилок і зробити це набагато краще, ніж раніше.
The software was already presented in a lot of conferences, international conferences like the ISPRS, the CIPA conferences, the FIG conference. The InterGeo, we have a YouTube channel and we have a website, of course. And the software was awarded with the first prize of the ISPRS CatCon competition, which is for the best e-learning software. And in 22, we got the Wichmann Innovation Award at the InterGeo for the best software development in the field of geoinformation. So that is a quite successful project. The project weeks, they have happened in Bamberg last year and in November this year in Valencia, Spain. As already mentioned, we compare simulation with real scanning. We have German, Ukrainian, mixed student groups. So last year, some female students from Kiev and Dnipro could travel to Germany. Unfortunately, the male students could not travel, of course, and they mixed up with students from Oldenburg and Bamberg and spent a week in a self-organized project. So they had to plan and to organize their work by themselves. They have to do data and quality analysis. They had to correct their mistakes. They had to repeat their measurements if it was not correct, do a final presentation, and got a certificate for participation and 3 credit points. So next, in 2 weeks, we will all travel to Spain and we'll repeat this in the environment of the University of Valencia, where part of our staff and your staff is now located. Here you can see some impressions from the project weeks. Very nice atmosphere, very productive students, very friendly, intercultural exchange, new friendships, etc. So all
успішний захід. Майбутня робота, звичайно, має бути виконана, і нам треба продовжувати роботу над розробкою програмного забезпечення. Ми будемо робити більші презентації наших результатів.
Of the free version of the software.
Більш ніж 800 завантаження у нас зараз є цього матеріалу, більшість в Україні, але власне і в інших країнах світу. Ми будемо надавати навчальні матеріали. Ми включимо також і мобільне сканування наступного року, оскільки це досить важливо. Це із автомобілів, із роботів можна використовувати. Це буде наш наступний крок. І будемо також робити заявку на додаткове фінансування, оскільки ми зможемо продовжити роботу тільки якщо буде бюджет. І ми з нетерпінням чекаємо такої можливості і думаємо, що буде нова програма співпраці, яку ми оголосимо в кінці цього року, яка допоможе в відбудові в Україні. Отже, будь ласка, слідкуйте за оголошеннями, і ми будемо щасливі з вами співпрацювати, щоб допомогти Україні отримати можливість відновитися після цієї жахливої війни і підготуватися до європейського майбутнього. Дуже дякую. Якщо буде залишатися часу десь в кінці, то я можу продемонструвати саму програму забезпечення. Якщо час обмежений, то так і буде.